Welcome to ClickMyProject.com. Now we are going to discuss about the project Local Similarity Siemens Network for Urban Land Change Detection on Remote Sensing Images. Now we are going to discuss about the abstract of the process. This system presents a recent technique for unsupervised change analysis that leads to the method of ranking the changes that occur between the two satellite images acquired at different moments of time in this project. The existing system of change analysis used the change vector analysis technique. This framework based on the representation of the CVA in polar coordinates. The proposed system of change analysis is based on the binary descriptor and uses the Hammond distance of the similarity matrix. Hence, this process is mainly proposed to identify the changes between the two satellite images in the specific period of time. For example, the one satellite image is taken from the previous or before the 10 years means the second satellite image will be taken at the same coordinates after the 10 years. Then we have to find out the predict whether the differences occurred or not. If the difference between the two satellite images is occurred means we have to find out which kind of the differences is occurred in that two satellite images. If the urban area is changes or not. If the urban area is changes means finally the process will indicate which kind of changes is occurred. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The working flow consists of the modules such as the image acquisition, pre-processing, segmentation, feature extraction, classification, and finally performance estimation. The first stage of the project is image acquisition. The image acquisition, the image is getting from the dataset image. In this dataset, there are several satellite images having the different coordinates as well as the different time periods. After getting the any two images from the dataset, we just move on to the second stage of the process, that is the pre-processing. In this pre-processing, we are going to do the image resize. Why we are using the image resize here in the sense, if the input two images having the two different type of sizes means it will be tough to calculate the difference between the one pixel to another pixels. So we have to resize the two images in the same ratio means it will be the good to find out the difference between the one pixel to another pixel. After doing the image resize, we just move to the third stage of the project, that is the segmentation. In this segmentation, we are using the morphological operators to segment the region. If the changes is done means the particular regions will be marked and then it will be segmented. Once the segmentation was done, the segmented images undergoes to the feature extraction. In this feature extraction step, it is nothing but the collection of data. We are using the feature extractions like Geber feature extraction, JANAC features, local features, and then the kernel PCS to extract the features from the images. After extracting this four kind of features from the image, we just move to the classification step. In this classification step, we have to recognize whether the changes is occurred or not. Once the changes is occurred means if what kind of changes is occurred, we have to classify this one. So we are using the CNN based classification to classify the which kind of changes is occurred or not. Then the finally performance estimations. So in this performance estimations, we have two kinds of performance parameters, that is the accuracy and sensitivity. By using these two parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main file.m and select the option run. Now you can see the folder in the name of dataset. Just open the dataset folder. After that, you have to select the any two images from the dataset. You can see the several images in this dataset. So first of all, I select this one, then click open. After the selection of the first image, similar to that, you have to select the second image. Now I can select the second image like this. Now the process will be done automatically one by one. Once everything was completed, I will explain the results one by one. Okay, now everything was fine. So first of all, the first image I have taken as an input, that will be taken as from the data set that is in the name of input image 1. After getting the input image 1, we have to select the second image that is also shown in the figure 2 in the name of input image 2. You can see the difference here, the input image and then the input image 2. Now some slight changes will be done. I will explain one by one. After the getting of the input image from the dataset, we just move on to the second stage of the project, that is the image resize. In this image resize, the image will be resized into 256 cross 256, which means the number of row will be the 256, number of column will be the 256. Why I am saying this one is the two images should be in the same dimension, then only it will be calculated the distance between the first image and second image. So you can see the difference here, the first image and the second image will be in the same dimension. After the resizing, we just calculating the features like this. Then the figure 5 shows the difference between the input image 1 and then the 2. So in which pixels the difference between the 1 and 2 will be having the difference values, that will be noted and then indicated in the yellow region. Finally, we have to classify which kind of changes is that. Changes is made by the buildings, so it will indicate as a changes as crowded building. Then this is a feature extraction. So before that we have discussed about the feature extraction. This is the feature extracted values. This will be represented in the table format. After that finally we have to estimate the performance of the process. This is the overall performance of the process, that will be in the terms of percentage. So overall accuracy, sensitivity, specificity and precision, those values are in terms of percentage only. Those values will be plotted in the graph also. Thanks for watching this video.